different production costs that are in put here. So the numerical that we saw, no? I'll be telling the numerical. So there were four factories, right? Four factories, A, B, C, and D. The unit production cost in them were, so the unit production cost in them were rupees 2, rupees 3, rupees 1, and rupees 5 respectively. Unit production cost in factories. Nextly, we had been given the production capacities, right? So production capacities were given to us. Production capacities were 50, 70, 30, and 50 units respectively. Right. These factories supply the product to four stores, demands of which are 25, 35, 105, and 20 units. So four stores were there, and demands of all these fours or these stores were 25, 35, 105, and 20 units respectively. Right. Lastly, they have told us the unit transport cost in rupees from each factory to each store is given in the matrix below. So they have given us the transportation matrix, right? And in that transportation matrix, you know, told us about A, B, C, D. These were the stores 1, 2, 3, 4. 2, 4, 6, 11, 10, 8, 7, 5, 13, 3, 9, 12, 4, 6, 8, and 3. And we were not told to determine the extent of deliveries from each factory to each store so that the total transportation and production cost is minimum. So total transportation and production cost is minimum. So that particular solution we had to find. So what is difference so if we if it would have been a normal numerical, they would have no they won't be giving us the different unit production cost, right? So no, it is assumed that the production cost remains same across all the factories. So all the numericals that we have seen before the variants, we covered like 2-3 numericals, which were the simple numericals in which we seen what is the basics of the transportation model. In that, you would have seen that the production cost of these factories were not given to us, and at that particular juncture, we had an assumption that all these factories were having the same production cost. But no, it is that particular assumption is actually not true. Why? No, because the factory is located at different places, different states. So the prices of the resources and no price of the all the materials, the labors and the machineries, even the land may be different, and there can be a different production cost across all these factories. So that particular factor has been taken into consideration, and if that particular factor is there, how to solve that numerical is to be that happens to be the variant of your transportation model as well. So here what we are going to do is we had this transportation matrix. So we are going to we have already seen this numerical. So what we did was we have converted the transportation matrix into the transportation matrix plus production matrix, right? So now how did we do that? So now we had this all values of unit transportation cost and the unit production cost. So we have factory A, B, C, D, and we have stores 1, 2, 3, and 4. So the production cost of these factories to each of the destination or each of the stores is already given. For example, factory A, the unit cost of transportation of a product from factory A to store 3 is 6, right? And likewise, the transportation unit transportation cost of your product from factory D to store 2 is 6. So this is the transportation metric, but the input about the production cost has also been given, and that we can take into consideration. So here we have that factory A is having production cost as rupees 2, factory B is having the unit production cost as rupees 3, C is having it as rupees 1, and D is having it as rupees 5. So this consideration can be put into the this can be considered as an input, and we can reframe our matrix. So what will happen across all the values of this factory A, we have the production cost as rupees 2. So this will be added, the value of 2 will be added, the value 2 will be added in each of the values of the transportation matrix across the row A. So you will be seeing that here it will be 2 plus 2 is equal to 4, 4 plus 2 is equal to 6, 6 plus 2 is equal to 8, and 11 plus 2 is equal to 13. Right? So for factory B, we have the unit production cost as rupees 3. So now this values will be what now? 10 plus 3 is equal to 13, 8 plus 3 is equal to 11, 7 plus 3 is equal to 10, and 5 plus 3 is equal to 8. Right? Similarly, for factory C, it will be the unit production cost is rupees 1. So 13 plus 1 is 14, 3 plus 1 is 4, 9 plus 1 is 10, and 12 plus 1 is 13. Right? And lastly, factory D is having the unit production cost as rupees 5. Adding that in the transportation matrix values, 5 plus 4 is equal to 9, 5 plus 6 is equal to 11, 8 plus 5 is equal to 13, and 5 plus 3 is equal to 8. So now this happens to be the new matrix for us, and now we are going to work on this particular matrix to further find out the optimal or minimized production and transportation cost. So the next steps here will be getting a WAM solution, that is the initial basic feasible solution, and lastly we are going to get the optimal solution. Optimal solution after checking the optimality by either stepping stone method or UV method. So I'm hoping that you have understood this, how to solve this numerical, or if you want to get the solution of this numerical, refer to the unbalanced transportation problem numerical, the variant that we have seen, and entirely we have kept the numerical was same. I included it was a combination of your unbalanced transportation problem and the different production cost variant. So that particular thing you can refer to, and the problem can be solved. Even you can yourself now take it as a don't refer to that numerical now. You have a numerical in front of you, and you can try solving it, and then cross check your numerical the answer that you have got with the previous answer that I have uploaded on the Google Classroom. So meanwhile, all